Good afternoon. This is lesson 5 of LR4 on CPCTC. Just a concept that I want to talk about real quick before I jump into it is once we know that two triangles are congruent, let's say that we knew that these two triangles are congruent by angle side angle. Right? At this point, now what we can do is we can say that any of the other parts are then congruent. So I could say that angle C is congruent to angle F by what we call CPCTC. That's a T. Okay, and what that means is corresponding parts of these triangles that we've proven congruent are then congruent. So we have to prove triangle congruence before we can prove parts congruent. Okay, that's basically what this slide here is saying. Okay, so let's look at the first example here. How I know right away that this proof is going to be CPCTC type proof is that these right here, the show statement, they're parts. Right? So if parts are congruent, I know I'm going to get there using CPCTC. That tells me that I'm going to say that triangles are congruent. Let's go BMC, congruent to triangle AMD. I don't know my congruence justification yet, but I'm going to get there in just a moment. So my first statement, I'm going to take the markings that I have, angle B congruent to angle A, as well as CM congruent to DM. I know those are congruent because they're given. And then the piece that kind of puts it together here, the unseen piece, is that this angle and this angle are vertical angles. So vertical angles are congruent. We just have to name them. So angle CMB would then be congruent to angle DMA. And there you go. You have a proof by CPCTC. Normally, well, hold on, I'm missing one piece. How do we know that these triangles are congruent? Well, we know by angle, angle, side, which we could also call side, angle, side. Normally, we're used to being done right there. We've proven two triangles congruent, but we're taking it a step further, and that can be identified here in the show statement. Let's try another one here. Okay, I see classic CPCTC. Okay, and that means I'm going to want to show that AE is congruent to BD. Okay, that tells me that I'm going to want two triangles congruent to each other. Okay, the first triangle I see is ADB. The second triangle I see is BEA. Okay, if you don't see that right off the bat, what I want to look at, I want to look at items that I know. Right? This triangle and this triangle, they got a reflexive property going on, as well as the fact that they contain both of those angles that are given. So let's go with our givens first. Given is that angle ADB, angle ADB is right here, is congruent to angle BEA, which is that angle right there. I also know that angle, oops, I'm going to put it over here. This angle right here is angle ABD, is congruent to this angle right here, which is angle BAE. Angle BAE. So let's separate those two, but they're both given, right? Now the connector here that we don't necessarily see is a reflexive property. So you got to put that together by looking at the diagram. And in this case, that would mean that AB is congruent to BA. And therefore, these triangles are congruent by, again, angle, angle, side. If you wrote side, angle, angle, that's fine as well. Okay, and our parts, AE then, and BD would have to be congruent. So AE would have to be congruent to BD because they're part of triangles that are congruent to each other. CPCTC. Have a great day. Talk to you later.